All right, so just to recap from last week on Friday. So when we are solving systems with word problems, first thing you need to do is read the problem. You can't solve the problem if you're not going to read it. After you read it, determine what's missing. There's going to be two things missing. Figure out what they are, make one of them X, make the other one Y. Set up the two equations, solve the two equations, and then check your answer. So remember, when we're solving it, we're either using substitution or elimination. Substitution is when you have X by itself or Y by itself. Elimination is when you have X and Y on the same side. So if that's one place you've been getting stuck with, substitution, X equals or Y equals. Elimination, X and Y are on the same side. So for the three examples we did last week, we did, first one was substitution, we did another substitution, and then we did one that's elimination. So we're going to keep mixing it up today, practicing both. So if anything, if you struggle with substitution, we got more practice. If you struggle with elimination, we got more practice. Now notice on the quiz, the word problems that you had, I had already set up. So all you pretty much had to do was read the problem and then solve it. On your unit test, there are 4 word problems. There are 4 word problems that I know of. I still got to go back and check it and make sure. Only one of those is set up for you. The other ones you're going to have to set up yourself. So if you know you struggle setting up word problems, that's when you need to ask. Any questions from anybody before we continue? Any questions about the wonderful young ladies in here? Any questions from the wonderful people at home? All right, so let's look at example number 4. So before we solve example number 4, take a minute. So let's read through problem 4 and then we'll start solving. So I'm going to annotate as I go along. So based off of what I think would probably be important. The sum of 2 numbers is equal to 27. The difference of those same 2 numbers is 41. Find the 2 numbers and then use them to evaluate the expression 2x plus 3y. So, what don't we know? We don't know the 2 numbers. So, first number, second. We don't know the 2 numbers. So make one of them x and make one of them y. Make one of them x and make one of them y. So we read the problem. We figured out what's missing. Now let's set up the equations. So, sum. Anybody remember what sum means? Addition. Add them up. So sum means addition. So that means if you take these 2 numbers and add them up, you should get 27. What about difference? Like a subtraction. So if you take these 2 numbers and subtract them, you should get 41. We're set up and ready to go. Any questions before we continue? You want to be straight? Okay. You good? You good? You straight? Okay. Let's see. For those of you at home, anyone have any questions before we continue? Oops. All right. So look at our two equations. It looks like we have both equations. We have x and y on the same side. It looks like we have x and y on the same side. So are we going to use substitution or are we going to use elimination? I hear one vote for elimination. I see two votes for elimination. So I heard substitution. Now, technically, you could use substitution to solve the problem. So if you use substitution to solve the problem, that means you're going to solve one of those. You're going to get either x by itself or y by itself. So you technically could solve it that way. What that means, though, is if you mess up solving it for x or solving it for y, you're going to mess up the rest of the problem. So you can do it that way. There's nothing wrong with doing it that way. It just adds another possibility for you to make a mistake. That makes sense? So, Landon, check your email. I just sent that notes page over to you. Just let me know when you got it. All right. So now let's go ahead and solve it out. So in order to do elimination, we have to have opposites. Go ahead. You do not have to write it as a point if we're doing a word problem. I mean, if you did, don't erase it. I mean, it is what it is. But not really erase it. So if it's a word problem, you don't have to write it as an word problem. So elimination means we need to have a pair of opposites. So look at your x's and look at your y's. Are either one of those opposites? I think the y's are. So remember, if there's no number in front, it's understood to be 1. So this is a positive 1, and that's a negative. Positive 1 and negative 1 are opposites. So your y's are opposites. So your y's are opposites. So that means the opposites cancel out, and you add everything else going down. So x plus x is 2x. 27 plus 41 is 68. What do we do to both sides? Divide by 2. Divide by 2. So we now know what the first number is. This 2? Yeah. So we have 1x plus 1x. 1 plus 1, 2. Good, go ahead. So, 4, you all straight? Any questions at home? Okay, we still got to find the other number. We got one of the numbers. How do we get the other? Plug it in. Does it matter which equation we pick? No. So, I'm going to pick the first equation. Why? I felt like picking the first equation. Take 34, plug it in for x. That means we have to get y by itself. Subtract 34 on both sides. And you get negative 7.
I have a question now.
Go ahead.
So before I realized that y's were like, they get canceled out. I put like a -1 and I multiplied the second equation by -1. So, but I still have the same
That's
answer.
fine. So if you didn't notice that right away, you could have, since the x's have the same number, but they're not the same sign. So you had to multiply times -1. So if you did it that way, that's fine. Janai, you good? All right, Naomi, you good? Everybody at home, you good? So we know that the two numbers are 34 and -7. So I found the two numbers. Then use them to evaluate the expression 2x plus 3y. So if I have 2x plus 3y, I know that x was 34. I know that y was -7. So that means I get to plug it in. So that should give you 68 minus 21. What that give you? 47. That's it. Jonathan? From the. Jonathan from the. No, I've had people in the first 6 classes, but this is the one class. It's this class and my 4th period class that I've looked forward to the most. Because y'all are my passion. Y'all my baby. I will be here the next 4 years. So hopefully I'll get to keep you all for at least 3 of them. Well, maybe not. Some of y'all are probably tired of my crazy stuff by now. Questions on example 4? So, it's not a hard problem. What was the hardest part about this problem? Finding x and y. Deciding what to do. Maybe setting up the problem. Once the problem was set up, it was probably very easy to solve it.
I have a question. How do you know where there's elimination from substitution? Like, just not reading it and then.
So the question was, how do we know whether it's going to be substitution or elimination? So remember, for substitution, you either want x equal to something or y equal to something. For example, x equals 3y minus 1, and y equals 2x. You want one of your equations to already be set up that way. For elimination, you want x and y on the same side. So for example, x plus 4y equals 12. 3x minus 2y equals 8. So you already want it set up. You can write it on there if you want to, Adam, because that page is yours to keep. All right, that's cool. So either way, so those are the 2 easy ways to figure out whether you are going to use substitution or elimination. So, any questions either at home or here before we do example 5? Let me know when you finish with that before I erase it. example 5. So just like example 4, I'm going to annotate it as if I was the one doing the problem. The length of a rectangle is 3 times the width. The perimeter is 48 units. Find the length and the width. Find the length and the width. So, it's blatantly obvious which two things are missing. Set is the problem. But, just in case you didn't know it, length, width. So your length, and you have your width. So length x, width is y. Length is x, width is y. So if you wanted to use L and W, that's fine, that's your choice. If you want to use different letters, that's fine, that's your choice. Just make sure you keep everything straight. Make sure you keep everything straight. All right, so just for background purposes, just in case some people may have forgotten, if you have a rectangle, you have a length, you have a width. The length is the same thing, left and right. The width is the same, top and bottom. And then the perimeter is 2 times the length plus 2 times the width. That's the formula for the perimeter of a rectangle. So now let's set up the two equations. Let's start with this first sentence. Can we make it bigger? The length of a rectangle is 3 times the width. The length of a rectangle is 3 times the width. So, anybody think they can give me that equation? Either here or at home. So, x equals 3 times, so since the width is y, so we use y. Yeah. But you were right. Everything you said was correct. Length is x, means equals 3 times the width, which is y. X equals 3y. X equals 3y. Any questions on how we got that first equation? Second equation. The perimeter is 48 units. The perimeter is 48 units. So what could the second equation be? Anybody? So 48 is, I agree with 48. So P is going to be 48. So L means length, and we're using x for that. So 2 times x plus 2 times, instead of w, we can use y. There you go. So there's our system. Any questions before we continue? Landon, did you get the notes that I sent you? Make sure you let me know. Again, those of you that are at home, if you got a question, closed mouths don't get fed. The four that are here are going to take my attention because they're right in front of me. So if they ask, I'm sure enough don't answer. So if you got a question, I can look back at the computer all I can, but you gotta speak up. So, just as Nyla said, we're gonna use substitution. So, if you remember what I just had up here, substitution means either x equals something or y equals something. We have x equals 3y. So take 3y and plug it in for x. So we're going to be using substitution for this problem.
Where do we get that 3 bucks?
This 3y? So x, so remember the length is x.
Oh, yeah.
Good.
I remember.
So take 3y, plug it in for x. 48 equals 2 times 3y plus 2y. Now we in business. We ready to roll here. What do we do next? Distribute. So 2 times that 3y is going to give us what? 6y. Oh, you're not doing it. So put it on there. Oh, okay. So 2 times 3y gives you 6y. And then you're going to add it. So you have 6y plus 2y. So that gives you 8y. And now what do we do to get y by itself? Divide everything by 2. So you get 6 equals 1. So that means our width is 6. Our width equals 6. We know half of this answer. So if we know what y is, what do we do with it? Plug it in. Doesn't matter which one we put it in. Nope. So, which one do you feel like putting it in? First one or the second one? Which one do you want? Second one it is. It doesn't matter which equation you put it in. It depends on just whichever one you feel like putting it in. So if you put it in the first one, you should get 18. We're going to solve it in the second one, and we should still get 18. So 48 equals 2 times x plus 2 times 6. Yes, go ahead. That was the first equation. So, since the first equation is already solved for x, we took 3y and plugged it in for x. So you take 3y, plug it in for x. That's where that 3y came from. Okay. Go ahead and solve it out. So 2 times 6 is 12. Subtract 12 on both sides. So that's 36. Divide both sides by 2. 36 divided by 2 is 18. So as long as you don't do anything mathematically wrong, you should still get the same answer. So your length is 18. That's it. I'm done. Fit everything back onto the screen.
Does she not know?
That's what people. It's okay. They get used to it too. They used to being. Any questions on example 5? We'll at least get through one more example today. So, get it, man? So, just because you chose the second one doesn't mean it wasn't right. Most people are going to choose that first one because it's a little bit easier. But the fact that you chose the second one, you still get the same answer.
How do you? Well, I don't know what it said.
All right, so y'all start reading example 6. A group of 40 children attended a baseball game on a field trip to see Trey's first game with the White Sox. Each child received either a hot dog or a bag of popcorn. Hot dogs were $2.25 and popcorn was $1.75. If the total bill was $83.50, how many hot dogs were bought? So remember, the first thing to any word problem is to read it. Even if you don't have a clue about how to solve it, first thing, read it, at least so that you can hear the words. Read it so that you can at least hear the words. But now, we're going to solve it. So what are the two things that we are missing? So we have number of hot dogs, so that's what they want us to get. But we also don't know how much popcorn we got. So there's always two things missing. They may not want the other one, but we still need both in order to solve the problem. So make one of them X and one of them Y. Make one of them X and one of them Y. So we read it, we identify what's missing. So I heard a couple people hesitate for a second and say, oh wait, do I use popcorn? Because they didn't say popcorn. So when you're identifying what you're missing, you still use popcorn to set up the equation. But when you give your final answer, the only thing we need is the hot dogs. You still gotta use both of them to set them up. So now let's go through the problem. A group of 40 children attended a baseball game. Each child either got a hot dog or a bag of popcorn. That means I can have a hot dog, I can have a bag of popcorn, but I can't get both. So it's either one or the other. So that means if 10 kids get hot dogs, then the other 30 have to get popcorn because you can't get both. So that means the number of hot dogs plus the number of popcorn, you go to it, has to equal 40. Number of hot dogs plus the number of popcorn has to equal 40. Because remember, you can have a hot dog or you can have a popcorn, but you can't get both. Any questions on that first equation? So now let's keep using the rest of the problem. hot dogs are $2.25. We don't know how many hot dogs we got, but we know that they're $2.25. So that's $2.25 times X, times however many you're gonna get. Popcorn was $1.75. We don't know how many popcorns we got. So if $2.25 got attached to X, what am I going to do with $1.75? Attach it to Y. Plus $1.75 Y equals how much money was spent? 83 cents. So there's our equation. Let's make sure that we used everything. Make sure everything's been used. Any questions before we continue? You good? I know you wasn't here for the first one. So let's take a second and think about this. Take a second and think about this. Are the variables on the same side, or do we have one of them set equal to something? You could if you want to, but based on how the problem is set up right now, what method would we use? This is an elimination problem. It depends on how comfortable you are with it. Now, if you're a person that's comfortable with substitution, then you can use that all day long. As long as the problem doesn't tell you to use elimination, you can do it whatever way you want. So if you're real good with substitution, use it as much as you can. If you're a person that's real good with elimination, use it as long as you want. The hints that I gave you are for those people who don't know when to use what. But if you know that you're more comfortable with substitution, do it that way. You will get no complaints from me. So we're going to use elimination because the variables are on the same side. So that means we need to get opposites. So we need to get opposites. So if there's no number in front of the letter, what's understood to be there? 1. Space. So 1 and 2.25, they're not the same number. 1 and 1.75, they're not the same number. So what did the problem ask us for? Hot dogs or popcorn? They didn't want to know how many hot dogs we want, so they don't care about the popcorn. So since we don't care about the popcorn, we're going to leave X in the problem and get rid of Y. I know what you meant. You're good. So we're going to get rid of Y. We're going to get rid of these Y's. So since they're not the same number, what can I multiply times 1 and get 1.75? What can I multiply times 1 and get 1.75? 1.75. 1.75, but it has to be negative because you need opposites. So we're going to take the top equation and multiply it times negative 1.75. But I need them to be opposites so that they will drop out. Any questions before we continue? Anything that was not clear, didn't understand, is a little lost, whatever the case may be. Again, don't be afraid to ask a question. Just because people in the classroom doesn't mean I'm not going to be my whole self. And those people that want to clown on somebody else, like I said all year, you don't want these problems. So, we're going to take the top equation, multiply it times negative 1.75. So, negative 1.75 times 1, negative 1.75x, negative 1.75 times 1, negative 1.75y. So the only thing that's hard about this right now is that they're decimals. The only thing hard about it is that it's decimal. You have a calculator, dude? Okay. You can use your phone. That's no big deal to me. Negative 1.75 times 40 is negative 70. So the top part is, the top equation's good. Take the bottom equation and write it underneath. Any questions before we continue? Again, we got rid of y because we don't need to know how much popcorn they're going to get. We only care about the hot dogs. So here's our opposites. The opposites drop out. Negative 1.75x plus 2.25x. What should that give us? .5. We got 0.5. Again, don't be afraid of the decimals. Decimals are numbers too. Negative 70 plus 83.50. What should that give us? 13.5. I didn't blow it up tonight. You guys good try. Trust me, I know where you're coming from. I'm legally blind. Divide both sides by 0.5. So x equals 27 hot dogs. You get 27 hot dogs. That's it. Problem's over. Any questions on example 6 before we start to wrap this thing on up? All right. Okay.